We're going to graph this polynomial given that it has a 0 at x equals -3 and that 0 has a multiplicity of 2. So if a polynomial has a 0 with as x equals -3, then we know if we run it through synthetic division, we should get 0. And that will also reduce this degree that was 4 to 3. So let's do that first. -3 is a 0, so we're going to run it through synthetic division. And we will get 0 because it's for the remainder, because it says that it's a 0. So this is going to be expected. If I don't get that, then I'm going to check my work for mistakes. So bring down the -1, multiply and add. You know what to do. It's 12, 17. This is negative. 3 times 7 is 21. 3 plus 2 is 5. Add, we get 60. 60 times -3 is -180. Perfect. So now we have a third degree polynomial right there. So we need to reduce it to a quadratic so we can work with it a second degree. So we need another 0 to do that. But it does say -3 is a 0 with a multiplicity of 2. So that means -3 happens twice. So we're going to keep going with our synthetic division. We're just going to run it through now with the second -3. So -1, multiply, you get 3, add, you get -1, multiply, 3, add 20, multiply, -60, perfect. So now we have shown that -3 is a 0 with a multiplicity of 2, and we have this remaining quadratic that we should be able to work with. Now hopefully it factors. If it doesn't factor, then you're going to have to use the quadratic formula. So we're going to continue looking for zeros by factoring. Now, this looks like an easy quadratic, but it's not +1 out in front. It's a negative. So you'd have to do the A times C method for this. However, you can factor out -1, or you can divide everything by -1, both sides, because we do have a 0 over here. So I'm going to divide both sides by a -1, just to make it easier to factor. So multiply this whole side by -1, and 0 divided by -1 is 0. So that allows me to do that, and it really doesn't affect anything. So now all I have to do is find factors of -20 that add up to 1. That's easy. It's +5 and -4. So my other two zeros are x equals -5 and x equals 4. So my zeros are x equals -3, right, with a multiplicity of 2. So it's going to bounce off that one because it's even multiplicity. X equals -5 and x equals 4. They both have multiplicity of 1, which is odd. So the graph will go through those intercepts. The only thing I have left to do for the graph is to use the leading coefficient test. So let me drag this down a little bit so we can look at the function. For the leading coefficient test, we're looking at the degree, which is even, it's to the 4th, and the sign of the leading coefficient. The leading coefficient is -1. So this does what a -x² would do, which is start down and end down. So that was the leading coefficient test. The one last thing you can see is the y-intercept. The y-intercept is 180. So when I graph it, I'm going to go, obviously this is not 180, but I'm going to go all the way to the top. It won't be that accurate, obviously, but at least I will have the shape. So let's do this. First of all, -3 is a 0. Remember, it's going to bounce. I'm going to do that in red so I remember it bounces. The other ones I'm going to do in blue. 1, 2, 3, 4, 5. -5, so I remember it goes through. 1, 2, 3, 4. Our graph is going to be, what color should my graph be? Let's make it, no, I was going to make it pink. Can you see pink? Not really. We'll do it anyhow. So it starts down. Now remember, the blue ones it's going to go through because they have even multiplicity. So I'm going to go through this one. I'm going to make a smooth graph because it's a polynomial, so a nice smooth turn. It's going to bounce off this red one, so again, a nice smooth turn on the bounce. And then it's going to go way up to 180, which I'm going to put way up here. And it has to come back down to go through this 0. It goes through it because it has an odd multiplicity, and it will end up down. So it did start down and end down. That is my graph. And that's it. It's pretty easy.